So our next unit is going to be where we're going to be taking our atoms, and up until this point we've talked about how electrons and protons are the same. But in this next unit, we're going to talk about how electrons can actually change, and they're no longer going to be the same as the protons. And then, so we're going to form ions by doing that. So to start talking about ions, we need to first review a little bit about valence electrons. So valence electrons, remember those are the electrons in the outer shell, the outer energy level. And remember that those energy levels can hold, the first energy level can hold 2, the second energy level can hold 8, and our third energy level can go up to 8 as well. And that fourth energy level, we're only going to have to go up to 2. So we're just going to focus on those first 3 energy levels. So group 1, remember group number goes with valence electron. So group 1 has 1 valence electron. Group 2 has 2 valence electrons. Group 13, now remember we skipped the transition metals and there's 10 of those. So instead of being group 3, it's group 13. Group 13 has 3 valence electrons. Group 14 has 4 valence electrons. Group 15 has 5 valence electrons. Group 16 has 6 valence electrons, and group 17 has 7 valence electrons. Now with group 18, our noble gases, they have 8 valence electrons, except remember that helium only has 2 because it only uses that first energy level, and that first energy level can only hold 2 valence electrons, or 2 electrons. Okay. All right, so we're going to learn something new now, Lewis dot diagrams. So Lewis dot diagrams are where we have the symbol drawn, and then we're going to draw dots around it to represent the valence electron. So we only care about valence electrons. So think about our Bohr model where we had our nucleus in the center, and then we had our energy levels, and we had our electrons drawn. Okay, now for the Lewis dot diagrams, we only care about the electrons that are in the outermost energy level. And those dots we're going to draw around the element symbol. So for hydrogen, as you can see, hydrogen has 1 valence electron because it's in group 1. So hydrogen gets 1 dot. Now we don't just draw these dots however we want. There is a way to draw them. So we're going to imagine that there is a box around the element symbol. And you start off by drawing 1 electron on each side of the box until you've drawn 4 electrons. So if we look at our box here, there's 4 sides to the box. You can start on whatever side you like, but once you start, you go clockwise or counterclockwise around the symbol. I find myself starting in different places almost all the time. There's no rhyme or reason for it, but typically you can start on the top or on one of the sides. And then I tend to go clockwise. So clockwise is that way. All right. And then once we have 4 total electrons, 1 on each side, then we begin pairing them up until we have 8 total. So you should never have more than 8 valence electrons, because remember, group 18 is our highest group, and they have 8 valence electrons, so we can never have more than that. So boron, the symbol is B, and it's in group 13, so it has 3 valence electrons. So I'm going to draw our box here. Okay, and we're going to draw, if we can start at the top here. So there's 1, and then we move to the side, there's 2, and there's 3. And so I have this drawn here. Looks like I started on the left side. It really doesn't matter as long as you have 3 electrons drawn and they're not paired up. They're on their own side. Okay. Oxygen is in group 16, so it has 6 dots or 6 valence electrons. So draw the symbol O. I'm going to draw my box. So I'm going to switch colors so we don't get them mixed up with the other dots that are on here. So O has 6 dots. So I'm going to start at the top. 1, 2, 3, 4. I have 4 dots. Now I can start pairing them up. So 5 and 6. And so that's why it looks like that. You can see the 2 of the dots are unpaired, or they don't have a friend. Or sometimes I like to call them lonely. We got 2 lonelies on oxygen. Okay? And you can see that these 2 have buddies. These are paired up. All right, and fluorine. So fluorine is F. It's in group 17, so it has 7 valence electrons, and we're going to draw 7 dots. So there's our box. You don't have to draw the box. It says imagine a box. I'm drawing the box to help you, but you don't have to draw the box. And as you can see, the finished product doesn't actually have the box in it. But while you're getting used to it, you can draw the box. You can think of it as a box. Okay, so 7 dots, 7 valence electrons. Start at the top. Work your way around. There's 4. We have 3 more to draw. So now we start pairing up. 1, 2, 3. 7 dots. Okay, so that's why the finished product looks like that. Okay. So you're drawing the valence electrons. You're just drawing how many dots around the symbol based on the group number. Okay, so group 1, 1 dot, 1 valence electron. Group 2, 2 dots, 2 valence electrons. 13 has 3 dots, so on and so forth, okay? Noble gases. So we've talked about the noble gases and how they have full outer energy levels, and that's what makes them so special. Well, they're actually so special that all the other atoms want to attain that same electron configuration. They want to have a full outer shell. They want their valence electrons to be full. That makes them very stable. To do that, though, that means that they either have to add more electrons, they have to gain electrons, or they've got to give some electrons away. They've got to lose electrons to fill their outer shells. Okay, so for example, let's look at magnesium. So magnesium has an atomic number of 12. So that means that to start off, we always start assuming that it's neutral. So if it has 12 protons, then it also has 12 electrons. So let's draw the Bohr model for magnesium. Okay, we'll just draw a circle for the nucleus. There's one ring. And there's another ring. Oh, man, I hate when it does that. Okay, let's try this again. There's another ring. Oops. Okay, come back. And we need a third ring. There we go. All right, so there's my 3 energy levels for magnesium. I'm actually going to copy and paste this because I'm going to do this again with a different element. Okay. So magnesium has 12 electrons. So remember, 2 can go in the first ring, then 8 can go in the next ring. All right, so that's 10 so far, so we need 2 more. So 2 in this ring. And notice now hopefully it makes sense why I'm drawing the dots in the Bohr model the way that I draw them. And it's because of the Lewis dot diagrams. Okay, so magnesium has 2 electrons in its outer shell. Now, it wants to have a full outer shell. What is going to be easier? Okay, so we have 2 options. We can either gain 6 more electrons to fill the current shell, or another option is if we lose these 2 electrons, here, that shell goes away, and then the next shell on the inside is full. So our other option is we can lose 2 electrons. Okay? So the atoms will do whatever requires the least amount of energy. So whatever number is smaller is going to take the least amount of energy. So 2 electrons is smaller or easier than 6 electrons. And so what magnesium is going to do is it is going to lose 2 electrons. Okay, gaining 6 electrons would take way too much energy. So if we get rid of these 2 electrons, okay, so now this configuration is the same electron configuration as neon. And neon is a noble gas. It has 10 electrons. Okay, but the atom is still magnesium because it has 12 protons. So what happens? What does this do to the atom? Well, it's going to make the atom form a charge. So it has 12 positives and 10 negatives. Okay, so this is now 10 electrons. So remember, this atom is not actually neon. It just has the same electrons as neon. Okay, we're still talking about magnesium. Okay, so I'm going to erase that so we don't get confused. Okay, so if I have 12 protons, 12 positive, and 10 electrons, 10 negative. Okay, so if we combine my positives and my negatives, I have 2 more positives now because I lost 2 negatives. Okay, so magnesium is then going to have a positive 2 charge because it loses 2 electrons. Okay, so another example we can look at is, let's look at fluorine. Okay. So fluorine has an atomic number of 9, so it has 9 protons. And always assume that it's neutral to start, so it's going to have 9 electrons. Okay, so let's go ahead and draw our electrons. So remember, 2 in the first, and then we can have up to 8 in the second, but we're not going to need 8 quite. We're going to need 7 because we want to get to 9 electrons. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 electrons. Now, remember, I'm going to erase this last ring because we didn't need it. Remember that we want to look like the noble gases, so we want to have a full outer shell. Well, the 2 options for fluorine are we can gain 1 electron because we have 7. Remember, this second shell can hold up to 8. So we can get 1 more electron and then we'll have a full outer shell. Or we could do like we did with magnesium where we lose all of our electrons in the outer shell and that'll get rid of it and the next shell on the inside is full. So we can either gain 1 or lose 7 electrons. Now they will do whatever requires the least amount of energy. So what's easier? Getting rid of 1 or gaining 7? It's always going to be the one that has the smaller number. So gaining 1 electron is going to be much easier than losing 7. So let's draw in 1 electron, and I'll draw it in a different color so we can see the one that we're adding. So draw 1 more electron. So since we've added an electron, we now have 10 electrons. And look at that. These 2 look the same. This looks the same as this. The only difference is the protons. The protons are different, which make the elements different. But the electrons are the same, again, as neon. Neon has 10 electrons, and again, neon is a noble gas. So they're trying to look like whichever noble gas is closest to them on the periodic table. So 10 electrons for fluorine then means that we have 9 positives and 10 negatives. So we have more electrons than protons, so their charge is going to be negative. and our charge is going to be -1. We have one more negative than we do positive. So fluorine's going to have a -1 charge. Okay, and you can actually write the symbol like that, where it's to the upper right of the symbol. So we can do the same thing for magnesium, +2. Okay, so we're trying to look like the closest noble gas with our electrons, just our electrons. The protons, if you change the protons, you're going to change the element, and we just want to have the electrons match. So losing and gaining electrons. If an atom has 1, 2, or 3 valence electrons, it's going to be easier to lose electrons. And just like you saw earlier, if we lose electrons, we become positively charged. Okay. Now, if an atom has 5, 6, or 7 electrons, it's going to be easier to gain electrons, and that will be negative because electrons are negative. If you're adding an electron, electrons are negative, you're going to get more negative. Okay, so group 1, it has 1 valence electron. It's going to lose it and become +1. Okay, group 2, it has 2 valence electrons. It's going to lose them and become +2. Group 13 has 3 valence electrons. It's going to lose them and become +3. So we said if it has 1, 2, or 3 valence electrons, it loses them, becomes positive. What about if you have group 14, if it has 4 valence electrons? You can lose 4 or gain 4. There's not an obvious choice there what's easier because they're the same number, lose 4, gain 4. So group 14 doesn't actually form ions. It doesn't give up or gain electrons. It's actually going to do a different kind of bonding called share. It shares electrons. Okay, so what we're talking about right now is ionic bonding, where we're either losing electrons or gaining electrons, but group 14 is going to share electrons. That's a different kind of bonding we'll talk about later. Group 15, so when we get to group 15, it has 5 valence electrons. Okay, now remember we want to get to 8 because the energy level can hold 8 electrons and we want to fill it. So we can either lose all 5 of our electrons or we can get to 8 by gaining 3, and 3 is fewer than 5. 3 is less than 5. So we will gain 3 electrons and become -3 with our charge. Group 16 has 6 valence electrons. We can either lose 6 or to get to 8, we can gain 2 more electrons. So we're going to do that because 2 is less than 6 and we're going to become a -2 with our charge. Group 17, these are the halogens. They have 7 valence electrons. They're 1 away from 8. They're very close. They just want to gain 1 more electron to get to 8, and that'll give them a -1 charge. And remember, we said group 18, those noble gases, everybody wants to be like them because they have full outer shells. That means they're already stable. They're not going to form a charge. They're not going to gain or lose any electrons. They already have everything they need. And the types of ions that we can have. So when we gain or lose an electron, we form an ion. So an ion is just a charged atom. It has a positive or negative charge. It has lost or gained electrons to become stable to form that charge. We lose or gain electrons to fill our outer shell. So that's what they've done, and they formed an ion. Now, if they form a positive ion by losing electrons, that's called a cation. That's why there's a little picture of a cat here. Okay, cats so cations are positive, and cats have paws. Positive. Okay, those tend to be metals in groups 1, 2, and 13. Now, anions form negative ions by gaining electrons. And the word anion kind of looks like the word onion, and onions make you cry. So onions are negative. Okay, those tend to be nonmetals in groups 15, 16, and 17. Okay, and we're going to stop there for part 1.